Hi everybody, welcome to today's tutorial. We're going to study chemistry today, the fundamentals of chemistry. Our focus will be on atomic structure. Before we go on with atomic structure, we are going to first of all understand the concept of the word element. An element in chemistry is any substance which cannot be split into two or more simpler substances by any chemical means. So let's look at the definition on the board. An element is any substance which cannot be split into two or more simpler substances by any chemical means. Sometimes we do not fully understand the meaning of the word element. We feel that it means a substance that is very hard, that we cannot break it. No, that's not what it means. Let's consider this rectangular piece of object to be an element such as iron. If by any means I cut this element, this iron, into small pieces, each piece remains iron. It cannot change another substance. So that definition does not mean that an element is so hard we cannot break it. No, we can break an element into 1 million pieces. Just like this rectangular piece of iron, which were broken down to square pieces of iron. Each matrix remains iron and retains the properties of iron. It cannot change to silver, neither can it change to gold, or neither can it change to another element. So the question is, can an element divided? Yes. When divided, can it change to another substance? No. So element is a substance which cannot be split into two or more other substances by any chemical means. Now, we'll go over to the concept of atom. Atom. What is an atom? An atom is the smallest particle of an element which can take part in a chemical reaction. Let's go back to the example used as an element, iron. If I have a piece of iron and I decide to use a machine or a milling machine to grind it into pieces, reducing the size into tiny pieces. Each piece here represents an atom of iron. Think of grinding a substance into powder to the point that you cannot reduce it again. The smallest bit of that particle represents what's called an atom. Now, a scientist known as John Dalton told us that an atom is indivisible. It is reasonable, it's logical to say that this small particle that you cannot grind again is indivisible, but it was proved wrong. The atom is found to be divisible by further experiment by some other scientists. What made the atom divisible? The discovery of the fundamental particles of the atom made it divisible. What are these particles? There are three major particles in the atom: proton, which are represented using P; neutron, which are represented using N; electron, which I represent using E. These are the three particles found in the atom. Now, where are these particles found? Location. The proton is found in the center of the atom. The center of the atom is called the nucleus. The neutron is also found in the center of the atom, also called the nucleus. While the electron is found revolving around that center, around the nucleus, in a circular part called orbit or shell. Having known that, these particles have charges. Yeah, they are charged particles. The proton were found to have positive charge. The neutron has no charge, just like the word neutral implies, neither positive nor negative. The electron has negative charge. Then, relative masses. Then, the proton has a mass of 1 unit. The neutron also has a mass of approximately 1 unit, while the electron has the smallest of the least mass, 1/1840, approximately 0.0005. So, looking at these particles found in the atom, we are seeing the locations: proton in the nucleus, neutron in the nucleus, electron in the orbit, otherwise known as shell. Proton has positive charge, electron has negative charge, neutron has no charge. Now, the mass of the atom is actually concentrated in the nucleus, which is the mass of the proton and the neutron. The electron contributes least to the mass of the atom, very small mass. Now, we should also know that among these three particles of the atom, the one that determines the chemical property of an element is the electron. Even though it has the least mass, it determines the chemical properties of an element. Then, these particles, who discovered them? Proton was discovered by 2 people who work independently. First one is called Eugene Goldstein, and the other man called Ernest Rutherford. So these gentlemen independently discovered the proton. Rutherford worked using what we call the alpha scattering experiment. By means of this experiment, Rutherford was able to prove that the atom consists of tiny positive particles at the nucleus. Now, these particles is what we call the proton. Then, the neutron was discovered by a man called Chadwick. He also determined that the neutron has no charge. The electron was discovered by a man called J.J. Thomson. Thomson discovered the electron making use of what we call the cathode ray experiment. The cathode ray experiment. We are going to treat this further in next subsequent classes. So, having done this, we are seeing proton, repeat again, was done by Eugene Goldstein and Ernest Rutherford independently. Rutherford made use of what we call the alpha scattering experiment. Neutron by Chadwick, electron by J.J. Thomson. Then the charge of the electron was calculated to be minus 1.6 times 10 raised to power minus 19 coulombs. This charge of electron was determined by a man called R.A. Millikan using what we call the oil drop experiment. So, with all the discovery, the atom was proved wrong by saying that the atom is indivisible. So, this scientist now reasoning that if the atom is indivisible, how is it that this atom being very small, still contain other particles inside of it. Then, looking at the structure of the atom, we already said that the atom has a central body called the nucleus. The solar atom will draw the central body and will position P and N in it. P and N represents proton and neutron. We now draw a circle around it. This circle is what's called the shell or orbit. Electrons revolve around this electron, revolving around the shell. So this is the nucleus. I come again. The structure of that was developed from the solar system. In the solar system, you have the sun at the center, and you have the planet moving around the sun in circular path. So this is what's called planetary motion of electron. Planetary, trying to compare the electron to the solar system. So this picture of the atom was given by Ernest Rutherford. So apart from discovering the proton, Rutherford also gave us the planetary motion of the electron around the nucleus. It's saying that the electron moves around the nucleus the same manner as the planets move around the sun. So having done that, we now look at what is meant by electronic configuration. Electronic configuration. How do we distribute electrons? Since the electrons are found in shells, how are these electrons distributed inside the shells? The system by which these electrons are shared in shells, what we call electronic configuration or electron distribution. How do we know how many electrons an atom possesses? And the number of electrons an atom possesses is equal to the atomic number. So for beginners, this class is meant for beginners. For beginners, we should know the first 20 elements in chemistry. The first element is called hydrogen. Atomic number is 1. Number 2, these numbers are the atomic numbers or the number of electrons in the atom. Number 2 is helium. Number 3 is lithium. Number 4 is beryllium. Number 5 is boron. Number 6 is carbon. Number 7 is nitrogen. Number 8 is oxygen. Number 9 is fluorine. 10 is neon. 11 is sodium. 12 is magnesium. 13 is aluminum. 14 is silicon, 15 is phosphorus, 16 is sulfur, 17 is chlorine, 18 is argon, 19 is potassium, 20 is calcium. Well, it may be hard for us to memorize this or know it, but there are many ways of doing it. You can form your own small poem or what we call mnemonics, a funny word remembering something. For instance, I can say, he has little brain, but cannot offer full 9 subjects. You got that? He has little brain, but cannot offer full 9 subjects, where hydrogen H, the first letter there is for hydrogen, the same H for helium, LI for lithium, brain, taking B for beryllium, B for boron, C for carbon, N for nitrogen, O for oxygen, F for fluorine, N for neon, subject, sodium, S for sodium. When we confuse why is sodium Na, sodium is Na because it comes from the Latin word natrium, water-loving substance, natrium. So have Na represents sodium, so using S as in the English spelling. Then cycle number 12 will say, may all stupid people stop calling a pen cat. May all stupid people, may M for magnesium, Al for aluminium, S the silicon, people, P for phosphorus, S for sulfur, calling, taking only C for chlorine, A for argon, potassium. Potassium, whatever applies, but also applies to sodium. Their symbols are derived from Latin words. Potassium is from the Latin word called kalium. Now we have Kb and then calcium. So I hope you have this. You have your jota, you can put them down. You look at all this, you see that you have these numbers is of paramount interest. These numbers are the atomic numbers. You have to know them serial like this. So I start with the first 20 elements. So the atomic numbers here are nothing but the number of electrons in their shells. For instance, the atomic number of hydrogen is 1. It implies that hydrogen has only 1 electron. Helium is 2, it means that helium has only 2 electrons. Lithium is 3, it means that lithium has only 3 electrons. Sodium is 11, it means that sodium has 11 electrons in the shell, and so on. So having done that, then how do we distribute these electrons? We now go back to shells. We mentioned shell. The word shell or orbit is defined as a circular part corresponding to definite energy levels where electrons revolve. So that is shell for you. So if I have the nucleus with proton and neutron, the circular part around the nucleus is shell. An atom can have as many shells as possible depending on its atomic number. In chemistry, these shells are named using alphabets, special alphabets. The first shell is called the K shell. Second one is called the L shell. Third shell is called the M shell. So the shells are named accordingly from K, L, M, N, O, P, Q, and so on. This is number 1, number 2, number 3. So this small n represent their positions. As we go on in chemistry, there's a special name we call this small n. This small n is called the principal quantum number. But we got it called the position for now, for your understanding. So this is number 1, number 2 shell, number 3, number 4, number 5, number 6, number 7. Showing the different positions of the shells around the nucleus. Then, how then do we share? Since we know that electrons are found in the shells, how do we share the electrons? That's what's called electronic configuration. Okay, let us start with hydrogen. Hydrogen, atomic number is 1. We'll make use of what we call, when we want to write the EC, we make use of what we call the duplet rule, and octet rule. Duplet rule specifies that the K shell should take maximum number of 2 electrons. Octet rule specifies that the L, M, and N shell should take maximum number of 8 electrons. So we make use of the duplet and octet rule in writing the electron configuration of the first 20 elements. For instance, look at hydrogen. Hydrogen has only 1 electron. We put 1 electron under the K shell. We know that K should take 2, but hydrogen does not have more than 2, more than 1. So you give that 1 to K shell. So the electron configuration of hydrogen is 1 under the K shell. Helium is 2. The number is 2. we still have 2 electrons under the K shell for helium. By so doing, helium has satisfied the duplex rule. Lithium having 3, we can't put 3 here because K shell obeys the duplex rule. So which means we should give 2 to K shell. Remaining 1, that 3 minus 2, 1. That 1 will now go over to the L shell. If I pick element like, let me just jump a little, element like carbon 6, I have 2, remainder 4. And I give 4 to the L shell. L shell will take up to 8 before you move to another shell. If I pick nitrogen, which is 7, I have 2 and 5. Let's go to a higher element. If I pick neon, that is 10, I give to the K shell remaining 8. Then L can take 8, satisfying the octet rule. If I pick element like magnesium, which is 12, I have 2, remainder 10, 8, 10, remainder 2, because it cannot take more than 8. Then remaining 2 now go to M shell. I will still continue to fill the M shell until the M shell reaches 8. In the case of chlorine, I have 17, 2, remainder 15, 8. 8 plus 2 is 10, remainder 7. We now have 7 there. If I pick argon, which is 18, 2, remainder 16, give this one 8, that is 10, remainder also 8, you can take 8. Because, as I said, the LOMN shell will not accommodate more than 8, based on octet rule. Then if I pick, for example, calcium 20, 2, 8, 8, remainder 2. That will go to N shell. Now, if you take a look at these examples, we see that some elements here have their large shell filled up. Large shell is also known as valence shell filled up. Like helium, the K shell is filled up with 2 electrons. Neon, the alone shell, the large shell it has, is filled up with 8 electrons. Argon, the M shell is filled up also with 8 electrons. That is, therefore, argon and neon, these 2 elements satisfy the octet state, while helium satisfies the duplex state. These elements are called noble gases, noble or inert gases. Okay, having done that, we're going to look at atomic structure. For instance, hydrogen, the electronic configuration is 1 under the K shell. If I want to draw the atomic structure, or that is called electronic structure of hydrogen, I will draw the nucleus and then I will draw the shell. You have only one shell, K shell. I'll now show the electron, or that one electron residing in the K shell of hydrogen. So this is the atomic structure of hydrogen. If I want to draw that of helium, 2, K shell has 2. I'll draw the nucleus of helium, have your P and N, and then draw the K shell, which has 2 electrons. I'll separate them north and then one south. Separate electrons using the cardinal points. You can put north, one south, or west and east. Okay, if I look at lithium, that is 3. Or let me go to a higher element. Let me use sodium 11. Write the EC first. 2, 8, 1. How do I draw the atomic structure? I'll draw the proton, P and N nucleus. I'll draw the first shell. This one is K shell, mind you. K shell with 2 electrons. 1 to separating them. A lone shell with 8 electrons. Cardinal points used. 1 north, another 1 south, 1 west, another 1 east. I have given 4, but I have 8. So when I'm giving 4, the 4 electrons to the 4 cardinal points, the remaining 4 now start pairing. I will now have extra 1 here, 5, 6, 7, and then 8 electrons. Then the M shell with only one electron. I can choose any of the cardinal points and put that one electron. So this is K, L, M. This is the electronic structure of sodium. Now, what of sulfur? Let's take one more example on this. If it's sulfur, the atomic of sulfur is 16, that atomic number is 16. Then K, L, M, 2, 8, 6. So how would I draw the atomic or electronic structure of sulfur? I will draw the nucleus. This is my P and N, proton and neutron. Then the K shell, one electron in north, one, I can still use west and make it uniform, either west and south, east or north and south. Then the L shell will have 8, one north, one south, west, east. You start now pairing the remaining 4, 5, 6, 7, and 8. Then the M shell is 6 electrons. Then also singly on the cardinal points 1, 2, 3, 4. Remember 2 now. I wanna have 5. Use any point and pair 6. That is this sulfur, K, L, and M. So you practice the remaining ones as you're looking at your view notes. Then, having done that, we are going to look at what is meant by atomic number and mass number of an element or of an atom. Atomic number and mass number. So what is meant by atomic number? What is meant by mass number? Atomic number and mass number. Now, when we have an element, let's say let X represent the symbol of any element. We could be oxygen, we could be chlorine, we could be hydrogen, or element of your own choice. Every element is associated with 2 numbers. One written as a superscript, one written as a subscript. So this one up is the mass number. This one down, subscript, is called the atomic number. For instance, I have oxygen written as 16,8. Here in oxygen, A corresponds to 16, the mass number, Z corresponds to 8, the atomic number. But sometimes, this oxygen can be written as O, we swap the numbers, putting 8 up and putting 16 down. When we do this, which of the numbers now is the mass number? It can confuse a student. The mass number remains the bigger number of the 2. So 16 is the mass number, also 16 is the mass number here. So whether the convention is changed, there's a swap, we'll have 8 down and have 16 down. The bigger number up and the small number down, or the bigger number down, subscript, and the small number as a superscript. The mass number remains the bigger value. Even in this one, we look at this example, which of the convention we already did is 31, the bigger number up, phosphorus, and the small number down. But somebody can write it as P1531. That doesn't matter. The atomic number still remains the smaller number, while the mass number still remains the bigger number, 31. So that it will not confuse you when you come across a symbol written like this or in that format. The mass number is the bigger value, the atomic number is the smaller value. So A is the bigger one, whether it's placed up or placed down, while Z is the smaller value. Then what is atomic number? Before we go to this lecture, we're going to look at these two and then take some examples and then wind up for today. Atomic number, which is Z, is defined as the number of protons in the nucleus of an atom. Number of protons in the nucleus of an atom. For instance, this element phosphorus has 15 as its atomic number. What it means that in an atom of phosphorus, there are 15 protons in the nucleus. The element oxygen has an atomic number of 8. It means in an atom of oxygen, there are 8 protons in its nucleus. So you have to understand the concept of the word atomic number. That refers to the number of protons in the nucleus of an atom. Remember also, I said today that the atomic number refers also to the number of electrons. Yes. So before we go to that, we can write Z equal to MP, equation 1. That means atomic number is equal to number of protons. Then we can see that atomic number is also the number of electrons, which you can call Ne, in the shell of a neutral or uncharged atom. Yes. We can see that atomic number is equal to number of electrons in the shell of an atom. That's the condition for this second definition. The condition is that atomic number, for atomic number to be equal to number of electrons, the atom must be uncharged, neutral. But this is the perfect way of defining atomic number. But this one has a condition for the definition. What do you mean by uncharged atom? For instance, if I look at oxygen, O, 816, atom of oxygen. I look at oxygen again, O, 816, and I put a sign on it. This atom is uncharged, but there's no sign, plus or minus sign on it. While this atom is charged, which we're going to learn, is called an ion. A charged atom is called an ion. Now, for this particular atom, the atomic number is 8. The number of protons is also 8. Number of electrons is also 8 because uncharged. But for this particular atom, getting a charge, the atomic number is 8. Number of protons is also 8. But number of electrons will no longer be 8, be different. That means for every atom, these two are constant. But this is only constant provided the atom has no charge. Look at this atom. This atom has a charge. You can see -2 on it. What it means that being charged, for this one, Z is equal to proton, also equal to, for this first one we wrote on the board, Z is equal to proton, equal to electron. The three things are equal, these three items, because the atom here has no charge. Then, for this one, we have Z equal to proton, but not equal to electron. Then, going to mass number. Mass number is defined as the sum. Mass number is the sum of the protons and neutrons in the nucleus of an atom. That means mass number is the sum of two things: proton plus neutron. When you add number of protons and number of neutrons, we get the mass number. So mass number is proton, but remember that as we said before, our atomic number is equal to number of protons. That means I can say that A will now be equal to Z plus neutron, because these two are equal to each other. So that is it, the lesson we have today. In our next class or tutorial, we're going to look at problems involving calculation on atomic number and mass number. Please, as you watch this video, like and share and drop a comment. Thank you.